In this video, we will talk about how to count the number of elements in two overlapping sets. So I want to motivate this with an example. So I'm going to let the number of elements in U, our universal set, be 30, the number of elements in A be 23, and the number of elements in B be 15, and the number of elements in the intersection of A and B be 11. And the question is asking us for two things. Part A asks us to find the number of elements in the union of A and B asks us to find the number of elements in the complement of that union. So I want to first do this incorrectly. I want to point out an incorrect solution because this is a common error that I see in questions like this, and I want to point it out so that you're aware of it. So in part A, for example, I'm trying to find the number of elements in A union B. So it could be tempting using what we learned in section 1.2 to say, wait, isn't this just the number of elements in A plus the number of elements in B? Because if we do that, and then I plug in for both of these, n of A is 23, and n of B is 15, and adding those together, I get 38. But looking at that answer, this is too big because the number of elements in the whole universal set is 30, so there's no way a set can have more elements than my universal set does. So this is clearly, something is clearly wrong, since the entire universal set only has 30 elements. And even though we're taking this union, A union B, that's still going to be something within that universal set. So it shouldn't have more elements than our universal set does. So what went wrong? So I want to remember and note that the number of elements in A union B only equals what we tried to say it was here, n of A plus n of B. It only equals that when A and B are disjoint. So when in their Venn diagram, A and B do not overlap. That's the only type of situation where the number of elements in the union of A and B would be equal to the number of elements in A plus the number of elements in B. So how do we do this correctly? So I'm going to show how to do this in two ways. So first I'll call this correct solution 1. And in my first correct solution, I'm going to point out that it is usually good to begin with a Venn diagram. So in these questions where we're trying to count the number of elements in some set involving multiple sets like this, it's helpful to begin with a Venn diagram. Okay, so I am going to draw a circle for the set A and a circle for the set B, and they may be overlapping. And those are contained in a rectangle, which I will call my universal set U. And after we have that drawn, I want to start labeling the different sections, starting with the inside and then working out. So I want to start labeling inside out. So for example, so if I zoom out a little bit so I can see the initial values, zoom it out a little bit more. Okay, so I can see that the intersection of A and B has 11 elements. So let's label that. So this is 11 elements. And then maybe I could try to find the number of elements in this section of A that is not part of the intersection. So I'm going to try to figure out how many elements go here. Well, whatever that number is, I'm going to just put a box for that. If I add that to 11, that's all the elements in A. And the question tells me that A has 23 elements. So I could just fill in the blank here. I do a little algebra. I can subtract the 11 over. And if I do that, I can see, oh, this has to be 12, because 12 plus 11 is 23. So there's got to be 12 elements there. Okay, if I do the same thing for this other region of B, I'll put a box there. And if I add that to 11, that's making up all the elements that are in B. And the question tells me that there's 15 elements in B. And if I fill in that blank, well, what plus 11 is 15? That's going to be 4. So 4 goes over there. And now I have those 3 regions of my Venn diagram filled out. So I have enough to answer part A of the question, finding the number of elements in the union of A and B now. Okay, so for part A, I can say that from the diagram, we see that the number of elements in the union of A and B is, and now if I add up those numbers, I get 12 plus 11 plus 4, and that gives us 27. And that's the answer to part A. All right, let's see if we can do B now. So B is asking us how many elements are there in the complement of that union. So N of A union B, complementing that whole thing. So I need to know the number of elements outside of that union. Well, the question tells me that there's 30 total elements in this whole rectangle. So all I have to do is just take that value, 30, the number of elements in the whole universal set, and subtract out the elements I don't want. Subtract out the elements in the union. So let's write down what I mean. So I'm going to do the number of elements in the whole universal set minus the number of elements in the union, because I don't want to count those. So the whole universal set, there were 30, and then minus, we just found there's 27 elements in the union, and that gives us 3. And that is going to be how many elements are out here in this region. Okay. It's often a good idea in questions like this, where we're filling out the different pieces of a Venn diagram, how many elements there are, to just do a quick reality check at the end, and make sure that all these numbers add up to how many elements the question said were in the universal set. So if I take the 3 and add it to the 12, to the 11, to the 4, if I add all those up, I can check that I do get 30, like the question says I should, and that's good. So I'll put a check mark there. So the question that I want to ask next is there a formula for the union, for the number of elements in A union B, when A and B are not disjoint, like they were in this question? And the answer is yes, there is. So the answer is yes, and I'm going to motivate this with a picture. So I'm going to draw a rectangle for my universal set, and I'll draw a circle for the set A, a circle for the set B, and again, I'm drawing the most general picture where I assume that my 2 sets might overlap. So to find a formula for this, I want to first look at why was the initial formula that we had from section 1.2, why is that off in general? So that formula involved taking n number of elements in A plus the number of elements in B and just adding them together. Why is this going to be off? So for the number of elements in A, what that counts is everything in this circle for A. So that gives us the number of elements in this region. Oops, sorry, just region, no plural. And then if I count the number of elements in B, that is counting all the elements in this circle, in this region. So I'm adding to it the number of elements in that region, in the blue region. So overall, when I add those up, everything in A and everything in B, I've counted this intersection twice. So this counts the number of elements in the intersection of A and B twice. And that's actually why it was off when I did it incorrectly first. So if I've counted that twice, I can fix this by saying, okay, my bad, I counted it twice. Why don't I just subtract the number of elements in the intersection? That way I only count it once. So subtract the number of elements in that intersection once. Okay, so let's take a look at this. That would give me that the number of elements in A union B, if I actually want to count this, I will find the number of elements in A plus the number of elements in B. But right now that's too big because it counts the intersection twice. So I'm going to subtract the number of elements in the intersection. That way now I'm only counting it once. And that is my general formula for the number of elements in A union B. So let's test this out on our question. Let's solve this using this formula. So this is going to be correct. Solution number 2. So using that formula, we get the number of elements. Let's use the number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. And I plug in for everything that I know. So number of elements in A union B equals, and the question said that A has 23 elements, B has 15, and the intersection, well, the question told us that that had, what was it? I think 11. So if I work out what this is, 23 plus 15, that's 38. 38 minus 11 is 27. And that is the same thing as the answer that we got the first way. So in the next video, we are going to do another example involving 2 overlapping sets like we had here, but it's going to be a word problem.